Good morning, student. Today we will study about the FET, field effect transistor. So here we will study about the introduction of field effect transistor, which is a very important topic for us. And in this topic, we will study about the structure of FET, field effect transistor, structure of FET, construction of FET, and working of FET, and difference between the FET and BJT. So here we will study about the field effect transistor, introduction of field effect transistor. So so field effect transistor FET is a three terminal device, semiconductor device, just like a transistor. हमने ट्रांजिस्टर पढ़ा था, बीजेटी पढ़ा था, बाइपोलर जंक्शन ट्रांजिस्टर पढ़ा था. Bipolar junction transistor also three terminal device, and FET is also a three terminal device. So uh, it is a FET is a three terminal semiconductor device, and important, it is a unipolar device. Just as BJT is a bipolar device, but it is a unipolar device, means the current flow in the FET only by the one type of charge carriers, either electron or hole, will take the part in the conduction of currents. So this is the important point of FET, field effect transistor. It is a three terminal device, just like a BJT, and but it is a unipolar device. It is a difference between the BJT and FET, because in BJT current conduction takes place due to the both type of charge carriers, electron and holes, whereas in FET the current conduction takes place either by the flow of electrons or by the flow of holes. So only one type of charge carrier takes part in the conduction of current. That's why it is known as the unipolar transistor. So again, the current is controlled. The output current is controlled by the electric field here. Hence, it is a voltage control device. Output current is controlled by the electric field, which is a voltage. So by the input voltage, we uh, control the flow of current. That's why it is known as the voltage controlled device. FET is a simple to fabricate and occupies less space, means its circuit density is very high. So on a small space we can assemble, or we can fabricate large number of circuits than BJT. So this is the biggest advantage of FET, that it is a higher circuit density than BJT. That's why uh, FET is useful in VLSI, very large scale integrated system. Very large scale integrated systems. Nowadays, we are using microprocessor mobiles. In those devices, we use the integrated circuits, and in that integrated circuit, we use FETs in place of BJT. So FET is very useful in VLSI, very large integrated systems, which are used in laptop, mobiles, and many other electronic equipment systems. Again, it is important point, it has high input impedance and low output impedance. uh, this against the repels from BJT, that BJT has high low input impedance and high output impedance, but it has low output impedance and high input impedance. So that's why it is used as buffer in front of end of voltage and other measuring devices. So FET is most popularly used as a buffer because it has high input impedance and low output impedance. Again, it has high coupling capacitance. As a result, they are used in hearing aids. And now the types of FET. So there are two types of FET. There are two members of FET. One is JFET, junction field effect transistor, and MOSFET, which is known as metal oxide field effect transistor. So these are the features of FET, introduction of FET. So here we have studied that FET is most popularly used in very large scale of integration devices because it has high circuit density. It has high circuit density. So that's why FET is used in uh, electronic devices in a very large scale integration system. So, and there are two types of FET, BJT and FET, JFET and MOSFET. These are the two types of FET, BJT and MOSFET. So, JFET can further divide into two parts, N-channel JFET and P-channel JFET, whereas MOSFET can further divide it into two parts, depletion type MOSFET and enhancement type MOSFET. Sir, we have write DE MOSFET. In some books we use DE MOSFET and E only MOSFET. So E only MOSFET refers to enhancement type MOSFET, where DE MOSFET is referred to the depletion type MOSFET, where depletion type MOSFET and enhancement type MOSFET is further divided to two parts, N channel JFET and P channel JFET, just like a JFET. And these are the symbol diagram. These are the symbol diagram of these are the symbol diagrams of FET. So it is a three-terminal device, as we know that, and these three terminals are drain, source, and gate. Each FET member has three terminals: drain, source, and gate. So this is drain, this is source, and this is gate. Drain, source, gate, drain, source, gate. So when the current is inside from the gate, this will be refers to the N channel FET. And when the current is refers to outside the gate, this is known as P channel JFET. So similarly, this is D MOSFET and this is enhancement MOSFET. So the gate is insulated. Here the gate, you can see that gate is, there is a distance between the gate source and drain because the gate is insulated by silicon dioxide layer. In here, all the FET members, gate terminal is insulated by the silicon dioxide layer. So there is a distance between the uh, source, drain, and gate, where here it is not, there is no distance between the source, drain, and gate, because here the gate is isolated by the silicon dioxide layer. So again, this is N channel if the current is inside, this is N channel, current is outside, this is P channel, N channel, P channel. Here the, since you can see there is a single line between the drain and source in D MOSFET, whereas line is break between the drain and source in enhancement MOSFET. So this refers that in depletion MOSFET, the channel exists. The channel exists between the source and drain. So that's why there is a single line between the drain and source. Here the line is break. This shows that the channel is not exist between the drain and source. So the line is break here. Again, junction field effect transistor. So as we have studied, it is two types of junction field effect transistor: P channel JFET and N channel JFET. So how we will construct the P channel JFET or N channel JFET? So in N channel JFET, for example, we have taken N channel FET. So N channel JFET consists of a rectangular bar, a bar of N type semiconductor. N channel FET, first we will take N type semiconductor bar and we diffuse two p-type semiconductors at the both sides of the bar. The drain and source terminals are made by ohmic contact at the end of p-type semiconductor bar. The majority charge carriers electrons can be caused to flow along length of bar by means of voltage applied between the source and drain. So in the since the channel is N-type semiconductor bars is used as a channel. So in N-type semiconductor, the majority charge carriers are the free electrons. So which will be cause the flow of current. So that's why it is known as N channel. So this is the circuit symbol. So here we have taken N-type semiconductor bar. This is the N-type semiconductor bar, and two opposite type of semiconductor P-type is fabricated at the two opposite side of the this N-type bar. So this will be P-type and this will be P-type. So this is the, and two terminals are taken from the uh, opposite type of bar, and one terminal is known as source and other terminal is known as drain. And the p-type semiconductor, from the each p-type semiconductor we take a terminal which will be interconnected. This terminal is interconnected to p-type semiconductor, and so this can be used, this can be assumed as one terminal, because these two terminals are internally connected. So there are three terminals: drain, source, and gate. So this is the symbol of N channel JFET, and this will be the P channel JFET. Now the working of N channel JFET operations. So this is the N channel JFET, and we can see that N channel JFET, as soon as the PN junction is formed, as soon as the PN junction formed, here we have PN junction is made, N-type semiconductor, as we diffuse the P-type semiconductor, and after diffusion of P-type semiconductor, the PN junction will be formed at the boundary of P-type semiconductor and N-type semiconductor. So as soon as the PN junction is formed, the dipletion layer is also created, and the dipletion layer will be created. So the width of the effective channel will also reduced. As soon as the differential layer created, the width of the effective N channel will be reduced. So this bit of dipletion layer is controlled by the voltage applied at the gate terminal. So dipletion layer, bit of the dipletion layer can be increased or decreased by the applying the electric field at the gate terminal. So if the dipletion layer will be increased or decrease, the path or channel width also increase or decrease, and the channel width also increase or decrease, the current is also controlled. Current will also increase or decrease in N-type semiconductor bar. So here we said this is the biasing. The drain is connected to the positive terminal of the battery, and source is connected to the negative terminal battery, and gate is connected in reverse wise. Gate and source will be connected always in reverse wise in JFET. So gate is P-type, so it is connected to the negative terminal of battery, and source is N-type, so it is connected to the positive terminal of the battery. So it will be reverse wise, and reverse wise field will increase or decrease the width of the dipletion layer. So the gate and channel constitute a PN junction, as we have already discussed. Diode, which is reverse biased by the gate to source voltage, right? So dipletion layer is developed in the channel. As the reverse bias is increased, the width of the dipletion layer is increased, right? So for the fixed drain to source voltage, the drain current will be the function of reverse bias voltage at the junction. Drain to source voltage, VDS is fixed. If this VDS is fixed, then current in the drain source current will be the function of this VGS. So at the gate source voltage, VGS is equal to VP, known as the pinch off voltage. This eliminates the channel, and the channel bit is reduced to zero. Not actually zero, it will be minimum. In that case, we can assume it will be the minimum at the pinch off voltage. So this is the drain characteristics, which is drawn between the drain source, voltage and drain current at constant VGS. So this you can see that this is the, you can see here from VGS is equal to 0 when the gate source voltage is 0, and if we increase the voltage, current will increase. ठीक है, but it will becomes constant. This current will becomes constant at a particular value of VGS, and this particular value of VGS is known as pinch of voltage. This is known as pinch of voltage. So pinch of voltage is the nothing. It is the drain source voltage at which the drain current becomes constant, right? So this is the pinch of voltage, and this region is when VGS is equal to 0 volt. This will be achieved as VGS equal to 0 volt. So first, when VDS is increased, the current will increase, and as soon as the current VDS becomes the BP, pinch of voltage, the current becomes constant. Now we increase the VGS. Now we increase the VGS, again current will increases, but it will not increase as much as it's increase at when VGS is equal to 0 volt, because this will reduce when we increase the VGS. The reverse bias voltage will also increase at the PN junction, which will increase the width of the depression layer. As and the width of the depression layer will increase, the channel width will be decrease, and the channel width will decrease, the current will also decrease. So the current here, you can see that current will decrease here, and the pinch of voltage also decreases here, and the currents become constant. Again, we increase the voltage, pinch of voltage will decreases, and it will early reach its maximum value. So this is the drain characteristics between the drain source voltage and drain current at constant gate source voltage. Again, so again we will study the difference between the or comparison between the BJT and FET. So as we have already discussed that FET is a unipolar device, because the current conduction takes part either the electron or holes, majority charge case, whereas VJT is the bipolar device, because the current conduction takes part by the electron and holes. Two type of charge carrier takes part in the conduction of current. Two types of charge carriers, electron holes, both takes part in the conduction of current. That's why it is a bipolar device. BJT, bipolar junction transistor, bipolar device. FET is a unipolar device, because the only one type of charge carriers, either electron or hole, either electron or hole, not both. So majority charge carrier, which will be the majority, are responsible for the conduction of current. That's why FET is known as UJT, UJT, where it is known as BJT. Second point, it is the drift mechanism withheld the movement of charge carriers. Due to the drift mechanism, the current will take part. Where here the current will flow due to the diffusion process. Here BJ more stable, FET is more stable than BJT, because the in BJT we have studied the collector current is temperature dependent. So it is, that is, we have to bias the BJT to get the stability, but it is more stable in comparison to the BJT. FET, again, FET is a voltage control device, because the output current is controlled by the input voltage, where the BJT is known as the current control device, because the output current is controlled by the input current. As we know that the input impedance is high of BJT, but the input impedance is very low in BJT. FET में इनपुट इम्पीडेंस हाई होता है, जबकि बीजेटी में इनपुट इम्पीडेंस हमारा लो होता है. Easy to fabricate, but it is not easy to fabricate. So that's why the FET, we have already stated, FET is used in VLSI systems. FET is less noisy as compared to the BJT, but the BJT is more noisy. It produces the more noise in the amplified signal. So this is the difference between the BJT and FET. So these are the important features between the BJT and FET. So again, in this figure, there is a one point is missed, that the BJT FET is a high circuit density, and BJT is not a BJT is very low circuit density. So high circuit density and low circuit density means uh, BJT, FET, more FETs, more field effect transistors can be fabricated on a small chip in comparison to the BJT. That's why FET requires less space in comparison to the BJT. So now thanks, and stay tuned and keep learning.